Test-driven development is an approach that is using unit testing to drive the design of your code. In test-driven development, you always write the test first. So the first thing you do is writing a failing test. Then when you are done with your test, you implement the code to make the test pass. You don't care about making the code really nice and so on. You just implement it with as less effort as possible to make the test green. When the test is green, you refactor your code and clean up everything. So for example, you clean up duplicate code, you're extracting classes to keep the single responsibility for a class, and so on and so on. When you are done with the refactoring, you write another test, and then you are again in this cycle. So in test-driven development, you always follow this pattern: red, green, refactor. When you write software, you build features that add value for the user. Such a feature consists of several small pieces of production code, the so-called unit that we want to unit test. When you use test-driven development, you should start by writing a failing test. So you think about that small piece of production code and how to test it. But you should also think about the possible solution to build the whole feature that consists of several small pieces of production code. And sometimes when you think about that possible solution to build that feature, there is a big question mark in your head. Sometimes you're not sure if your idea will work or not. And if that's the case, it makes no sense to start with a red failing test for a small piece of production code. Instead, you first need to find out if your idea will work or not. And you can do this with an experiment. You can just say, let's hack the idea down without tests to see if the idea will work or not. And such an experiment is called a spike in TDD. So let's look at the definition. A spike is an experiment without tests to ensure that your idea will work. In a spike, you don't care about writing nice code. You just hack your idea down to see if this is the right way to go. After you have found out that it is the right way, then you should throw away your spike. And then you start by writing a failing test, and then you're back in the cycle of test-driven development with red-green refactor. Okay, now let's switch to the friend storage application and let's create a spike for the navigation view model so that we can find out how to load the data items. Before we start writing tests for the friend storage application, we will look at the navigation. We want to spike the loading of the navigation items. So let's switch to Visual Studio and let's spike that part. Here I'm back in the friend storage solution. Now let's spike the loading of navigation items. Let's first take a look at the main window. When I click on the navigation view, you can see that its data context property is bound to a navigation view model property. The main window should have the main view model in its data context. And so the main view model should have a navigation view model property that contains the navigation view model. So let's create that property here. Okay, we make the setup private and we just initialize that property in the constructor. Alright, now we also need to pass the main view model to the data context of the main window. So let's go to the main window's code behind file and let's add a constructor parameter here. Okay, we use the main view model and we assign this to a field that we call view model, and we can generate that field with the Visual Studio bulb here, and then we assign it to the data context property of the main window. We also add an event handler for the loaded event here. And when the main window is loaded, we just call on our main view model the load method. That does not exist, so let's generate it. I go to that load method, and on that load method, I just call on my navigation view model a load method, so that the navigation is loaded. I also generate that load method in the navigation view model. And let's make the method public. Alright. Now before we switch to the navigation view model, there is one more thing we need to do for the main window. Now we have that constructor that needs a main view model. So at startup, we need to provide that main view model to the main window. So let's go to the app.xaml file and let's remove here the startup URI property. This property points to the main window XAML file, and so the application will create a window and show it at startup. But the application tries to call a default constructor, and now we don't have a default constructor anymore. So let's remove that property here. And let's go to the code behind file, and here let's override the onStartup method. Here we can create now a new main window, and we just pass in a new main view model to the constructor. Okay, we need to add some namespaces here: friend storage UI view model and friend storage UI view. Alright, and now on the main window we just call the show method. Okay, so that's it. Now we can continue in the navigation view model. So when the main window is displayed, the loaded event handler is executed, and that calls the load method of the main view model. In the main view model, we then call the load method of the navigation view model. And so here we are in the navigation view model. And here we need to load the items. Let's make that method public and let's just hack it down. When you look at the navigation view, you see that it contains an items control that is bound to a collection of friends. In the data template here, you see that such a friend is displayed with first name and last name. So these are the properties that we have on the friend model. Now we only need to load the friends in the navigation view model. When you look into the data access project, you see that I have here a file data service that we use to load and save friends into a JSON file. This file data service has a method getAllFriends. And this just returns an IEnumerable of friend. So exactly what we need in our navigation view model. So let's go to the navigation view model and let's just use the data service here. Okay. And then we create a public property of type observable collection of friend. And we call that one friends. We make the setter private. Okay, I also need a namespace for system collections object model. Then we just fill that property. So we say for each friend in data service getAllFriends, and then on our observable collection we add that friend. Okay, so that's it. Now one thing you might notice, this collection is not initialized when we call the add method. So let's initialize it in the constructor. Okay, let's save this and let's run the application. Okay, here we go. Now on the left side, we see we have loaded the friends into the navigation. Now we have spiked it and we know that our approach works. Now in theory, we should throw away our spike. But in fact, let's just keep the spike to see how we can refactor existing viewModel code to make it testable. So now let's try to write a test for that load method of the navigation viewModel. In the previous demonstration, we have spiked the navigation viewModel. Now we want to try to write a test for the load method of the navigation viewModel. So let's go to our test project and let's go to the navigation viewModel tests class. Here I create a new test method. As we are using XUnit, I use the fact attribute. For this attribute, I need a using for the XUnit namespace. I call the method shouldLoadFriends. Okay? The first thing I do in this method, I create a new navigation viewModel. And I need the namespace friendstorage UI viewModel. Then on this viewModel, I call the load method. And finally, I want to assert that I have some friends here. But now the question is, what number do I expect here? Is this a 2 or is it something else? Here we see a red underline because we don't have the friend class available yet. So in our test project, we also need a reference to the friend storage model project that contains the friend model. So let's add that reference to our test project. Okay, now when I go back to our test class, the red underline disappears. But now the question is, how to assert this? When we look at the navigation viewModel, we see that we are using the file data service in the load method. So our unit test is not repeatable in any environment because it is accessing the file system. Now you could also think of this as another service, for example a web service. Then our unit test would even access the network by calling the load method of the navigation viewModel. Somehow we need to move out the file data service dependency from the navigation viewModel to make it testable. And this is exactly what we will do in the next module. So let's wrap up now what you have learned in this module about unit testing and test-driven development before we continue with the next module where you learn how to write testable viewModels.